Hello friend, so in this video we will solve the workout examples of SC Verma from the first chapter. So guys, let's start with the first problem. So here is the problem. Find the dimensional formula of the following quantities. The first is the gravitational constant, that is what? G. So one thing is very common, that the formulas is given here. So since formula is given, so it's become really easy for us to make this. Like as we'll see, formula is given, F is equal to G m1 m2 by r square. So let's do here calculation. F is given G m1 m2 by r square. So if you need to find the G, so this F into r square, this will give you what? F into r square upon m1 m2, that is equal to G. So guys, for force, the dimension will be, since force, let's do it here. Well, force is mass into acceleration. Mass dimension is m, and for acceleration it is L t raised to power minus 2. Why L t raised to power minus 2? Because acceleration will have the velocity upon time, and velocity is what? Meter per second, right? Correct. So for meter it is L, and for time it is t, but again one more t is there, so it will be t raised to power 2. So overall acceleration will have L t raised to power minus 2, and mass will have m. So overall force, dimension of force, we can write this as a m L t raised to power minus 2. So just I replace the force, dimension of force, okay, and then we have r square is there, which is the distance. We can write this as a L raised to power 2. Distance will have dimension as L. M and m2 is nothing but the mass, so represented by m. Square is there, so just write it 2. So finally that is equal to G. So if we find one of the m will get cancelled from here, and m numerator it will become m inverse. So it will be m inverse here, as you can see. L raised to power 2 is there, and L raised to power 1. So overall it will give you L raised to power 3, and then last t raised to power minus 2. Guys, so this will be the dimension of the gravitational constant G. Let's talk about the next, which is surface tension. So for surface tension, I'll suggest you using, I have one easy formula, that surface tension is equal to force per unit length. This is the definition. Okay, so if we'll discuss about the force, as we have discussed, force is ml t raised to power minus 2. Let's discuss about the length. Length is L, so this L will get cancelled, and I will get m t raised to power minus 2 only, right? I'll just write it once again, m t raised to power minus 2. That is the dimension, right? But in this work example, which is given in the SC Verma, they have used this method, that formula. So I'll suggest you, rather than this, you can use direct formula. We have that surface tension is equal to force per unit length. This is very easy, right? Just think, you can refer anyone. I just suggest you to refer surface tension dimension as a force per unit length. This is the definition for surface tension. You will come to know once you'll read some other chapters related to this. Let's talk about the thermal conductivity. For thermal conductivity, we have formula Q is equal to, that is heat energy, K times of A is here area, theta 2 minus theta 1. Theta 2 and theta 1 is here temperature, theta 2, theta 1 is temperature, and D is the thickness, so they will have the L as a dimension. Well, let's see, first of all do the calculation. So if you do the calculation, so Q is there, D will go this side, and A will comes in denominator from here, theta 2 minus theta 1 as well as comes in denominator, and T will comes in denominator. So finally the value will have as a K equal to this. This is the value we have. K is equal to, the formula will have, here is the formula, sorry, K is equal to Q D. I just write it here, we will get better idea. Like K is equal to Q D upon A into theta 2 minus theta 1, then thickness. So guys, I'll just tell you about the heat. Heat is nothing but the energy. So for energy, we'll have the dimension as a force into displacement. You can use this one, work done is equal to force into displacement. So overall the energy will have the dimension as a ml2 t raised to power minus 2. I use this concept force. Force will have the ml t raised to power minus 2, and for displacement I'll have to multiply it by L. So overall I got it like ml t raised to power minus 2. Then I need to multiply by thickness. This is the thickness here. Thickness is nothing but the length, so let L represent it. What about the area? So area, it will be L square. Now guys, very important concept I am going to discuss now, that theta 2 minus theta 1 is there, right? That is nothing but the temperature. So temperature is represented by K. But remember one thing, whenever it is subtraction or addition is there, you just have to write a single term, because the SI unit will remain same. Like if it is 10 meter per second and plus 20 meter per second, so overall it will give you 30, which that is the magnitude, and magnitude does not have any dimension, and the SI unit will be single for both the term, like meter per second. So even if it was the subtraction were there, so we use only single Kelvin, one dimension for both of this, theta 2 minus theta 1, and at last for time it will have like capital T. So just do the calculation now. L2 is there, right? So guys, here is the values for dimension, just do the calculation. So we'll have L2 will get cancelled, right? One L is there. So at last do the calculation and we'll get the answer as a this. Okay, got it? Well, let's discuss the next now. Next one is D part. So let's start with the D now. So here is the formula, like F is equal to that coefficient of viscosity n, which we have to find this viscosity part. Okay, so first of all just write the formula and we need to find the viscosity. Okay, so guys, we have formula like F is equal to eta, which we have to find A V2 minus V1 upon T2 minus T1. Let's find the eta first. So eta will be, this will get multiplied here, so this force into T2 minus T1 upon A is the area, V2 minus V1. Okay, so let's talk about the force. Force will have like ml t raised to power minus 2. Okay, then what about the area? So guys, area will be nothing but L square only, meter square. Let's talk about the velocity. This V2 minus V1 is here, right? So velocity is there, guys. T2 minus T1 were there, right? So for T2 minus T1 will have like T only, right? Temperature, as I told you, that subtraction will be nothing but the temperature. Like T2 minus T1 will have the T only, the dimension, single T, and A for A will have the L square, and V2 minus V1 is nothing but the velocity, so it's a meter per second, right? So it will be L T inverse. Just do the calculation. So finally you will get eta as a m L inverse t raised to power minus 1. That will be the our dimension of this. Okay, well, let's discuss now for the question number 2. So first of all we need to discuss about the charge. So guys, you must have learned about the charge, and the charge is nothing but the formula Q is equal to IT, current into time. Even it is given here, right? So well, for your information, the dimension of current is nothing but the I, and time will have the T only. So overall it will have IT. Okay, that will remain same. Let's talk about the potential. So guys, for potential, first of all we have to use the formula that potential that they have given, like U is equal to VIT, and V is the potential. So let's V is equal to U by IT, right? Okay, where U is the energy, So for energy, if you don't remember, just remember this force into displacement. Force will have ml t raised to power minus 2 and displacement will have L. So overall the energy, whenever energy will be there, so it will be ml2 t raised to power minus 2, and for current it will be I, and for temperature it will be I only. So we'll overall will have the V potential have the dimension as ml2 t raised to power minus 3 I raised to power minus 1. So this will be our dimension. Getting? Guys, let's discuss the next one, which is for the capacitance. So for this we have given that the formula is Q is equal to CV. So from we need to find this C capacitance, so Q by V. Q is IT, which is charge, so this remain as it is IT. What about the potential? We just got the value of potential, that is nothing but ml2 t raised to power minus 3 I raised to power minus 1. Got it, guys? So basically at last we'll have, after this cut part M inverse is there, it will give you I raised to power 2. So overall this M is there, right? So finally we'll have M inverse, because M is there, M in numerator will become inverse. Overall L will have like L raised to power minus 2, because L raised to power 2 is there in denominator, so it will become minus 2. If we're talking about the I will become I raised to power minus 2, and T will be nothing but T raised to power 4. Guys, I will be here I raised to power 2. If I raised to power 1 is there, a minus 1 will become plus 2. So overall the dimension will be have M inverse L raised to power minus 2, I raised to power positive 2, T raised to power 4. Got it? I hope this is clear to you now. Now let's discuss the last part, which is for resistance. Well, let's talk about the resistance. So this formula you are familiar in 10th standard. Okay, so let's tell me about the formula. First of all, V, let's V is equal to IR. So from there we will get R is equal to V by I, and V is nothing but the potential. We just find it the value. So let's say we just put the value of potential here, this V and I as it is. So finally we will get this as also. Okay, once you find the potential, you know how to find the potential using the formula. I just show you once again that the potential energy is equal to VIT. From there we will get V as a potential energy upon IT, and energy is nothing but the work done is equal to force into displacement. Got it? Okay. Well guys, in this problem the question is like the SI and CGS unit of energy are joule and erg respectively. How many ergs are equal to 1 joule? So first of all you have to talk about the energy. So for energy we'll have the formula as energy is equal to, what is the formula? You can use the Einstein theory, like E is equal to mc square, right? M is nothing but the mass and this velocity square, right? Well, let's now do for mass. So mass will remain as it is. For velocity it is length by time. Okay, so mass will have the dimension m and velocity will have LT inverse, but since the square is there, so it will become L raised to power 2 and T raised to power minus 2. So overall the dimension will be m L2 T raised to power minus 2. Okay, but now just discuss. If you look here, I just written already like 1 joule, that is equal to, mass is there. For mass in SI unit, the mass will be in kg. Remember guys, in SI unit you can use this either, if you don't remember, MKS, mass. Okay, so this is for the distance meter, mass will be in kg and time will be in second. Okay, for CGS like centimeter, gram per second. Okay, let's discuss once again now. For mass, m is there, so it will be kg, 1 kg. Length will be in meter, as we discussed, it's SI unit MKS, and the time will be 1 second. But you have to remember, since it is L square is there, so 1 square. Since T raised to power minus 2 is there, so 1 second raised to power minus 2 will be there. Now let's discuss about the erg. 1 erg is equal to in CGS. So now mass will be in gram, since GS is there, gram, then length will be in centimeter, 1 centimeter, square will be there, and time will be in second. So if we'll divide it, I'll get joule per erg. So let's find the value. 1 kg upon 1 gram, 1 meter upon 1 centimeter, second, time with time. So finally we find 1 kg is there, right? Let's convert it into the one term, like 1 kg can be written as a 1000 gram. You must know about this. This 1 gram as it is, keep this 1 gram. This kg will become gram. 1 meter can be written as 100 centimeter, right? And this, keep this 1 centimeter as it is. But remember one thing, this was having the square, right? This having the square term, and the second will remain same, 1 second and 1 second in CGS as well as in MKS, SI unit or CGS unit. So let's discuss now. There it was 100 is there, so 100 will become a square is there, so 100 will become 2 more 0 will be added, and for this will remain same. So this mass will have 3 zeros, so overall will have 10 to the power 7 values. Got it? So basically one will have 10 to the power 7 erg. I hope I'm clear with this. Now let's discuss the next problem, which is Young modulus of steel is 19 into 10 to the power 10 Newton per meter square. Express it to dyne per centimeter square. Here dyne is in CGS unit of force. So first of all, Young modulus is SI unit is given Newton per meter square. Newton is nothing but the applied for force, or meter is for distance. So anyway, the formula for Young modulus will be now force per unit, the distance is square. So force will have the dimension as a ml t raised to power minus 2, and the distance, keep this L2. So one of the L will get cancelled, we'll get the dimension as a ml inverse t raised to power minus 2. Now let's use the SI unit concept. So 1 Newton meter square is there, so Newton. So for mass we'll have the 1 kg, for length we'll have the 1 meter, and for time we'll have the 1 second. When in CGS 1 dyne per centimeter, for the mass will be now in gram, meter will be in centimeter, like distance, the second will remain the same. So once in the same way the previous problem, once we divide this 1 Newton per meter square upon dyne per centimeter square, just put the value like mass of the SI unit first, just put the value of mass unit, mass, and the CGS is in gram, then the 1 meter upon 1 centimeter, time will be for 1 second each. So now we need to convert into the CGS. So once again 1 kg will there, kg will be converted into a gram, so we'll get 1 kg is 1000 gram. This one will remain as it is. 1 meter is there, so guys I'll just do it here for you. 1 kg were there, 1 kg will become 1 gram, 1000 gram. This 1 gram as it is, gram SI unit will cancel. Okay, 1 meter is there, so 1 meter can be written as 100 centimeter, 1 centimeter as it is, but inverse is there, so it will get reciprocal. And if it is 1 upon 1 second raised to power minus 2, doesn't matter. So guys, this 1000 is as it is, there it is 100, inverse is there, so this will become 1 upon 100. So finally we'll get 10 as answer. That is our answer. Got it? So basically 1 of Newton meter square is nothing but 10 dyne per centimeter square. Hence, since 1 Newton is equal to 10, for 19 into 10 to the power 10 we'll have 19 into 10 to the power 11 dyne as per the given question. Got it? Let's discuss about the next one. The velocity, time and force were chosen as the basic units. Well, in this question we don't have to consider the velocity as mlt raised to power minus 2. We just have to consider the velocity as a v, or velocity or force as f. So we need to find the dimension of mass. So for mass we know the formula is force is equal to mass into acceleration. So for mass we can write force is equal to mass into acceleration. Force as it is, mass as it is, and acceleration is velocity per time. We are looking for mass only, so force time will get multiplied, and that is the velocity, the mass, right? So just write this ft velocity inverse, that is nothing but for mass. Got it? So that is our answer. I hope this is clear to you. In case if any doubt, you can give me in the comment box. Let's discuss about the next question, question number 6. Here we need to just test the dimension. Again, let's test this So okay, so here is the question. Well, the question is v square is equal to u square plus 2s, which is very important formula we need to check, guys. So let's take the LHS first. In LHS, left hand side we have v square, that is a velocity, and we know that velocity is nothing but LT inverse. Make it a square, so we'll get L raised to power 2 t raised to power minus 2. So this will be the one side. So we have to just add u square plus 2s. So addition will have the same dimension, we know that. So let's do it. U square, again a velocity, LT inverse. The square will give you L2 t raised to power minus 2. And 2 as is there. So 2 will be not having any dimension, magnitude. A is the acceleration, so it will have L t raised to power minus 2. And then we'll have L again for this x distance. So overall it will have L 2 t raised to power minus 2. So guys, we find it, the LHS is equal to LHS, because the remember guys, addition of this u square dimension and 2s is same. This must be same, and don't add or make this twice, because the dimension will remain same either on addition or subtraction. We have already discussed on the previous problem, but we have to just equate with the LHS. So LHS is equal to RHS, hence it is dimensionally correct. Let's talk about the next problem. Distance covered by time is given as a x is equal to a plus bt plus ct square plus dt cube. So x is given, we need to find the dimension of abcd. So guys, here a plus bt plus c t square plus dt cube is there. So all will have the dimension as the same, since addition is happening. I just give you example, like you can't add apple with the mango, because these are the two different quantities. We can add only in one condition, and both will have the same quantity, like one apple with 3 apples. So we'll give you the 4, and the second it will be like apple. Got it? So the dimension must be same. Let's talk about this x. X is nothing but L. Let's discuss, equate it with the a. So a will have nothing but the dimension as L. Okay, we can equate directly x with this, x with this, one by one we can equate. Okay, let's discuss for bt. Bt is equal to, now x is nothing but L. So b will have L t inverse. Got it? Let's discuss about the third one, that is ct square, that is equal to L for x, again for x. So let's see, will have L t raised to power minus 2. Got it? T. For last, d is nothing but again dt cube, that is equal to L. So d is equal to L t raised to power minus 3. Okay, so this will be the dimension. Got it? No problem. Well, let's see the 8th number problem. With a centripetal force is directly proportional to we have given that force is in the form of mass raised to power a, velocity raised to power b, and r, which is distance raised to power c. So just equate f directly proportional to m raised to power a, v raised to power b, and r, distance raised to power c. We know dimension of m is nothing but mlt raised to power minus 2. Okay, just for m, mass will have a, velocity will have lt inverse b. Okay, and see the L. So L will have the C. Okay, this was B. So now equate. On LHS we have ml t raised to power minus 2. On RHS we have the single term of m, so m raised to power a. If we're talking about the L we have two terms, L raised to power b, and there we have L raised to power c. So just add b plus c. If we're talking about the t we have t raised to power minus 1 into b minus b, and we don't have any other term to equate, right? So finally we'll get this part. You got it? How we can dot this one. Now equating part. On equating m with m, so m raised to power 1 is there on left hand side, and then it is on right hand side m raised to power a. So a raised to power 1. If we equate with this, we'll get b plus c is equal to L as a 1, right? B plus c is equal to, there we have L as a 1, and for t we'll get minus b is equal to minus 2. So get b as a 2. So finally if you'll see here, we got b as a minus 2. We have already got the a. So once we'll put the value of b here, so we'll get the value of c as well. So finally just put the value m raised to power a, so m raised to power 1, then v raised to power b. So b raised to power b is nothing but 2, and the length, which is r raised to power c, which is -1, so it will become in denominator. So f is directly proportional to m v square by r, or you can write f is equal to mv square by r. So that was the value for this. I hope it is very clear to you. Okay, now let's see the remaining two problem. So now the question will be 9. So let's discuss the question number 9. Here is the question: when a solid sphere moves through a liquid, the liquid opposes a motion with a force F is equal to, force is given F, the magnitude of F depends upon the coefficient of viscosity. So it's like kind of the what it depends. So F depends upon directly proportional to the viscosity of the liquid, then the radius, let's say radius, and the sphere of the velocity or speed. So F is directly proportional to nRV. Just to remove the directly proportional, write it by K RV. Force will have the dimension as a mlt raised to power -2. This K as it is. Okay, this is not a dimension, by the way. Even you can ignore this K constant term, ignore this. Neta is there. Okay, so neta is nothing but the coefficient of viscosity, right? So guys, we have already discussed about the coefficient of viscosity in the previous problem. Like it will be m L inverse t raised to power -1. So power is here A, right? So let it by the A for neta, and for length let B, and for the, it also depends on the velocity. So velocity is there. So LT inverse, you can say C. So on equating, we will get on left hand side we have mlt raised to power -2. On the right hand side we have m. Let's see how many m terms are there. Single term. So m raised to power a. Let's talk about the L raised to power minus a. There we have L raised to power b plus b, and L raised to power plus c. Now let's talk about the last, which is t raised to power minus a, t raised to power minus c. Why c? Because 1 upon t is there. So finally we need to just equate. M raised to power 1 is there, so a is equal to 1. So we got that value. L raised to power, again here L raised to power 1, and now but in this side you will find L raised to power minus a plus b plus c, that is equal to 1. Just keep this as it is. We'll put the value of a from here, and once we equate this minus a minus c, which is for t, that is equal to -2, right? Now I will put the value of a from here first. So I'll get -1 minus c, that is equal to -2. I'll get c as a, this minus will become plus, so I will get c as a 1, right? So at last I'll just put the value of c and a here in this equation. So I'll get b as a 1. So guys, finally just put all these a, b, c. So all of them are 1. So f directly proportional to 1 1 1. A, b, c are 1. So we'll have the answer as f is equal to k and rb. K is any constant value, doesn't matter for us in dimension. Let's talk about the last problem. The heat produced in a wire carrying electric current depends upon the current, the resistance, and the time. So basically it depends upon the current, resistance, and time. Let's say the power heat depends upon, means current. So current raised to power a. We don't know the power, hence just write the resistance raised to power b, and time raised to power c. K is the dimensionless. So for heat is nothing but the energy. So the dimension will be mlt raised to power -2 on the left hand side. On the right hand side we'll have I raised to power a. Resistance we have already discussed in the previous, so it will be ml2 t raised to power -3, I raised to power -2, and t raised to power c. You can equate as the previous way, and on equating we'll get like this. Let's see m. So m will have like m raised to power, here 1 is there, and here it is m raised to power that b, right? This raised to power b. So basically we'll have b as a 1. Okay, now let's discuss the other part, like L raised to power 2, and here we'll have L raised to power 2 into b. So we'll have 2b as a 2, and second b as a 1. No helpful that much. But if we're talking about this t raised to power -2, and here that it will be like t raised to power -3b plus t raised to power c. So overall we get minus 3b plus c, that is equal to minus 2. We got 3 raised to minus 3bu and plus c here, and t raised to power minus 2 from here. One last we equate for I. So guys, for I we'll have I raised to power a and I raised to power, where we have any other I values, yeah, here it is I raised to power, there we have I raised to power minus 2b. So finally we'll get I raised to power a minus 2b, that is equal to, we don't have term on left hand side, so it is equal to 0. So just put the value of b, so we'll get the value of a. So we'll have now a and b and c as well. So finally we'll put it here. So h is equal to I square into rt. Guys, so this was the all over the solution for this work problem. We'll make the video for the exercise as well. Thank you for watching. If you like this video, please give me a thumbs up so that I just make some more video for you. And if you want to see some more videos, please subscribe it. Thank you.